An important point to make is that logistic regression works well with separating linear data. It does not naturally work well with separating nonlinear data. To illustrate this, I'm creating a fake data set. This is going to be a series of XY coordinates, and the target is whether or not the XY coordinate lies above curve given by y equals 0.5 to the x. So remember that for a binary classification problem, we need to have it in such a way that the target is either 0 or 1. And if it's not naturally in this form, then we need to convert. If I look at a scatter plot, it's clear that there is a separating curve here. And in fact, we know that there's a separating curve because we put that separating curve in ourselves with the way that we created the data. However, the separating curve is not a line. I'm going to introduce a logistic regression object here and then do the things that we've done before, where we train and we test and we fit. You'll notice that the score on the training data and the testing data is pretty good. There's not a lot of evidence of overfitting. Now I'm going to get the coefficients of the separating line that we can talk about in another video, but for right now, just believe me that this red line is the line that was found by the logistic regression algorithm as being the best line for separating the data. Notice that we didn't do anything wrong and the score is pretty good. There's just this part of the data that we're not going to be able to do anything about if we're trying to work with a line, because a line can't separate nonlinear data. If we use a transformation, we might be able to make the nonlinear data more linear. So I'm going to introduce log transforms of the variables by using the .map command. What .map does is apply the function to a column in a data frame. And if I look at x versus log y, it actually looks like I'm getting now linear separation. I have replaced y with log y, and if I repeat this and I draw the line of best fit, you see that that is absolutely perfect separation. So by introducing a transformation of the data, we made a separating line possible, and this separating line is basically perfect.